So, in this video, we're going to give you a quick introduction to one of the problems in problem set 2 related to electrocardiograms. So what is an electrocardiogram? Well, it's an electrical recording of the voltage differences between different regions of the heart. So you have a SA node, which is the first region of the heart to generate electrical activity, and it spreads from the SA node through the right atrium, RA, towards the left atrium. And so when it is high in this region and still low in this region, you get the top of a P wave. And then as it spreads and becomes more uniform throughout the atrium, then you get the lower part of the P wave right here. And then the QRS part of the EKG or electrocardiogram happens when you get depolarization down the septum, this middle region, down into the right ventricle and left ventricle. And then as it catches up and is uniform throughout the heart, then the R wave comes down. And then finally, you get the T wave, which is when the electrical activity kind of reverses course and it repolarizes. So you get this T wave right here. So you got several different features of electro activity in the heart that can be measured in this electrocardiogram, and so that's why it's useful clinically. So just to emphasize that a bit more in an animation, you get the atria generating the P wave. Then when you get depolarization of the ventricles, you get the QRS complex. And then when you have repolarization going back the other direction, then you have this T wave right here. So this, I'm not going to play this right now, but this is a interesting clinical recording of ventricular fibrillation, both when you have abnormal activity in the heart that could lead to sudden cardiac death, and also how that gets normalized with electrical shock. So in this problem set, we're going to be using data that was generated and deposited in PhysioBank, which is one of the main databases for electrical recording. And so this is a really useful resource if you're trying to test out different coding strategies for analyzing biological data. That you can go to this and find a lot of different types of data sources. So we'll be using some of the PhysioNet data that's already available in Scientific Python or SciPy. But if you're not using stuff that's already built into SciPy, then you would want to get a CSV file or Excel file that contains the data from one of these databases, and use like the read CSV file or command in pandas, or there are some other data loading commands also available in Python. So specifically what you'll be doing is generating or first loading and then plotting data that looks like this. So the raw data you see as here are some at least somewhat normal EKGs, and then you get some very abnormal EKGs and a lot of noise around here that is signs of an arrhythmia. And so it's important in this plot that we see with the y-axis and a y-axis label. We see an x-axis. Note that this is in units of time, so you'll need to do a unit conversion so that you end up in units of seconds. There is a legend, and as you notice, the R peaks are labeled with yellow X's or yellow or orange X's. And so you're going to be using the find peaks command in order to detect those. And it's important in this case that you there's a setting that you'll find out or explore to find that dictates how high the peaks need to be recorded. And so that will have to be done in your problem set so that you don't pick up at the peaks on all of these different P and T waves down here. You only want to be detecting the R peaks. So that'll give you a little bit of an introduction to dealing with real clinically used biomedical data in Python. Hope that is fun for you, and I'll see you next time.